Let's see, what do we mean by degree of a polynomial? So in very simple terms, and trust me, it's a very simple concept, the degree of a polynomial is basically the value of the highest power of the variable in the given polynomial. Polynomial variable in the given polynomial. So we have a polynomial. This is the first and foremost condition, that degree is only valid when the given expression would be a polynomial. And in polynomial, the powers of the variable, the exponents of the variable are non-negative integers only, which means the powers of the variables can be 0, 3, 5, 1, 98, 72, something like this, but it cannot be negative value. So the degree of a polynomial would only be non-negative integers, because that's the only possibility of a power of a variable. So that's why degrees are always non-negative integers. And secondly, I would again repeat this, that degree would only be defined when we would have a polynomial. So in a polynomial, the highest power of a variable would be its degree. And let's develop good understanding of this degree by solving these examples given here. For example, in the first one, what would be the degree here? I would like you to pause the video, try these 4 questions on your own, and then let's discuss the solution together. So for the first question, we have 4x square plus 5 times m to the power 9. Here the exponent of x is 2, and here the exponent of this variable m is 9. So irrespective of what the variable is, and they can be totally different variables, we only have to focus on the powers. So here the power is 2, here the power is 9. Obviously 9 is greater than 2, which means the degree of this polynomial would be equal to 9, the highest power. Let's try the second example. Here for this variable x, the power is 42. For this variable x, the power is 0. This is a valid polynomial because we are looking for non-negative integer. 0 is non-negative. So this is a polynomial, first condition satisfied. And now we would see which is the highest power. So 42 is greater than 0. So the degree of this second polynomial would be equal to 42. Let's try the third example. Whoa, this is slightly different because in the single term, we have 2 different variables. We have y square z to the power 3, and in the second term, we have 3.2 times m. So if there is no power written here, this means that this is m to the power 1. So what would be the degree in this case? So in such cases where we have more than 2 variables in a single term, we would add the powers available here. For example, the total power of this term would be 2 plus 3, 5. 2 plus 3, 5. And this has no significance. Trust me, you won't use it anywhere. It's just for the sake of identifying the degree of a given polynomial. So for this term, we would add up the powers. 2 plus 3, this is 5. So a total power of 5 would be considered for the first term. For the second term, we have m to the power 1. So the power here is 1. 5 is greater than 1. So the degree of this polynomial would be equal to 5. Sum of the powers of y and z. Similarly, let's try this last example. For this first term, again, we have 2 variables. So the total power that we would be taking for this term would be 2 plus 9. And I'm again repeating this. This has no mathematical significance. It's just for the sake of calculation of degree. So for the first term, we would have 2 plus 9, that is 11. For the second term, again, we would add up the powers, m square, y square, so 2 plus 2, 4. And similarly, for the third term, we would add up 5 and 9, which is 14. So out of 11, 4 and 14, 14 is the highest. So degree of this fourth polynomial would be equal to 40. So this is how you identify degree of a given polynomial.